morning, guys. My name's Alex and I'm an educator at the Emerald Coast Science Center. Today's activity is homemade ice cream and we're going to learn the science behind it. So for the activity, you're going to need some heavy whipping cream or some milk. Higher fat content, the better. At the end, you'll probably find out why and thank me later. So we're also going to need some salt, some vanilla, some sugar, and then a baggie of ice. You want about 4 cups of ice in that bag. You're also going to need a little baggie. You might notice that I am going to have 2 sets here. I'm going to be showing you guys a bit of a controlled experiment just to show you what that salt does to this. So we're going to go ahead and get started. So in one of your small baggies, we're going to go ahead and pour about a ½ cup of milk or cream. I'm going to go ahead and do this here. Into my second bag. You guys don't need that second bag at home unless you want to see the difference between them. Just go ahead and carefully pour that in there, make sure that there's no mess. We're going to add a 1/4 teaspoon of the vanilla extract. Add some flavor in there. And then we're going to add 1 tablespoon of sugar. So I have a ½ tablespoon here. I'm just going to add 2 of these because we need 1 total. Let me see. And then we're going to go ahead and seal that up. Make sure that you have it definitely sealed because we're going to be shaking this up a lot and you don't want to mess. There. Okay, so we've got our 2 baggies sealed nice and tight. We're going to take our bags. So this one has no salt in it. And this one, we're going to be adding salt. And so for that salt, you want about a ½ cup. All right, we're just going to pour that right in there, sprinkle it all over that ice. All right, open those up. Our no salt is going to go right in the labeled bag, zipped up nice and tight. Our salt go in the bag with the salt. So for this next part, you're probably going to want some kitchen gloves, just like these oven mitts. So you can use these, or you can use a towel, just wrap the bags up. There's that. There's that. All right, now you can take notice of the bag of ice. No salt. With salt. I'm just going to open this up. my baggies in there. And then I'm just going to use a towel in between there, just that way the temperature doesn't get affected. And you're going to shake this up for about 5 to 10 minutes, and we'll see what happens. I'll be right back. Alrighty, and we are back. So now we are going to unwrap and see what we've got. So here's our bag with no salt. You can kind of see the consistency. My bag is turned upside down, so much shaking. And then here's our bag with the salt. So you can see it looks a little bit different. My bag is crumpled up in there. So we're gonna just open these up. I'm gonna check the temperature of these real quick. Let's see. Turn our thermometer on. But I have it stuck in the ice. Let's see. Don't know if I can turn this around while I'm videoing. I can't. So you can see our temperature there. That is 2.8 degrees Fahrenheit. Now keep in mind that is the bag with the salt. So give me 1 second, you guys are gonna look up at my ceiling. I apologize. And we are going to look at the bag without salt. So I don't know if you guys can see, that says about 32 degrees Fahrenheit still. So you can see there's a big difference when we add salt. Alrighty, so we're gonna remove that. Now, let's see how our ice cream turned out. Alright. So it spilled a little bit in the bag, I think. As you can see, that's still pretty liquidy. Let's see if we can get closer. And then I can pour this out. Yeah, it didn't freeze too well. So we'll just put that back in there. I'm gonna go ahead, and instantly you can already see how much more frozen that is. And so we open that up. Let me get out a spoon. You can see the frozen chunks already. That is just solid right there. Drops right back in the bag. You can see in there. Alrighty. So you can go ahead and taste test your ice cream. Put any toppings you want on it. See how things turned out. It's pretty good. And I'm glad I went with the cream. Alright. So now we're going to need to talk about the science behind it. Let me get to a more comfortable position, clean this up, and we'll get into it. Now that we finished our activity, we can go ahead and start talking about the science behind all of this. So we're going to start off with talking about states of matter. Do you guys know any examples of states of matter? So states of matter include solids, liquids, and gases. So a solid has a fixed volume and a fixed shape. So for example, I have an ice cube here. It's got a fixed volume, fixed shape, it stays there. As I click on it, you can hear it. It doesn't have a liquid or a gaseous state. It remains in one solid block. A liquid has a fixed volume but not a fixed shape. So for example, I'll take my ice cream bowl here and just pour some liquid off. And you can see that flow. And that liquid does have to adapt to the shape of the container that it's in. So it does change over time. And then a gas doesn't have a fixed shape or volume. It does have to expand and occupy any available space. And so it depends what kind of surface it's on. Sometimes you might blow gases into a small space. If you think about blowing up a balloon, it has to occupy that tiny little space. But also gases can take up space all around us. And so in an open area, you might see different clouds or vapors move. So as an example, I have a hot plate here, and we're just gonna witness a solid turn into a liquid and then into a gas. And so we're gonna take our ice cube here, like we said, solid, and we're just gonna put it on this hot plate. And it's gonna start to melt, you can kind of see. So here it is, you can kind of see the bubbles around it as it boils and heats up. And so these states of matter are temperature and pressure dependent. So as temperature increases or decreases, the state of matter could increase or decrease. And so you see the bubbles, that solid's almost completely gone. And we're just gonna wait for it all to turn into a gas. You might see some steam come up. I'll just put it right here for you to see. And so our solid has completely disappeared at this point. We have nothing but a liquid on our hot plate. And so we're gonna talk about melting point and freezing point. And so the melting point is when a solid turns into a liquid, as you've just witnessed. And then the freezing point is when a liquid turns into a solid, so vice versa. So for example, when water is put into a freezer, it turns into a solid by becoming an ice cube. And so water becomes a gas at 100 degrees Celsius or 212 degrees Fahrenheit. It becomes a solid at 0 degrees Celsius or 32 degrees Fahrenheit. So they're the same temperature, just different ways of measuring it. And so that means that water maintains its liquid identity between 0 degrees Celsius and 100 degrees Celsius. So it has to be within that little range. And so pertaining to today's experiment, we had milk. So the freezing point of milk is determined to be at negative 0.5 degrees Celsius or 31.09 degrees Fahrenheit. So it takes a lot more energy to freeze the milk than it would for water. And so that's where the salt came into play in today's experiment. And this is bubbling a bit. You might be able to see. Kind of see in this area where the steam is popping up. And so that's our water taking on a gas form. And so as time goes on, the volume of that water will decrease. There won't be quite as much water there just because it is turning into a steam. And it is going elsewhere, it's just not present there. And so I'll just leave that on for you guys to kind of see over time as it changes. So back to what we were talking about when the salt comes into play for this activity. Let me just turn this temperature off real quick so I don't get a little bit hot. So the salt causes the freezing point of the ice to decrease. And so that is called a freezing point depression. And so because it's lowered that, you saw that our ice actually reached, I believe it was 2 degrees Fahrenheit, and the bag without the salt had somewhere between 32 and 35 degrees for its temperature. So as you can see, that salt does a lot of difference. The milk needed to be below 32 degrees, and because our bag without the salt didn't reach below 32 degrees, we weren't able to freeze our ice cream. So that mixture just remained a liquid, whereas our mixture that went into the bag with salt turned into a solid, and so it froze, and we were able to do that without using a freezer of any kind. So the salt allows for the ice to stay colder for longer as our milk or cream mixture lowers its temperature. The ice cream base freezes below 32 degrees Fahrenheit, and the salt ice allows for us to cool the base enough so that it starts to thicken and freeze before the ice melts completely. The melt ice and the salt slush mixture is colder than the straight up hard ice cubes. If we used only ice and the ice cream base, only made it to 32 degrees Fahrenheit. Like I said, it isn't enough to freeze that. So this is a great example of why colder states would use salt trucks in order to lay salt down on the roads. That way when snowfall hits, it hits that road that's covered in ice and salt, and that salt causes the ice and the snow to melt. So the ice that's already on that road is going to melt, being put under that sheet of salt, and anything that falls down after there reaches that salt and it just melts instantly. So there's no time for it to become ice again. But the salt trucks do need to keep laying down salt just to maintain that. The salt won't last forever, and it does get washed away when that ice and that snow turns into a liquid and just washes it off the roads and into the grass or the runoff. That is it for today's activity. If you have any questions, feel free to put them in the comments of this video. We are still unfortunately closed. However, you can still support us. Go ahead and take a look at our website, take a look at our previous videos. If there's activities that we haven't done that you want to see, feel free to comment, let us know. We'll try to make it work, and we'll find ways to do that. You can donate to us, or you can also purchase a membership. The start date won't start until we are open back up, but that does last a year, and it gets you unlimited visits to our facility when we are finally open. And you can talk to some of our educators. We can show you some more really fun activities. But make sure you guys stay tuned in. We're still continuing these all month long while we're closed. We are doing these at 10 a.m. Some of them are live, some of them are at home. So we'll just hope you guys have fun with all of these. Thank you.